All right, here are solutions for quiz 3 for Math 211. You're given some information about the Mayan number system and asked to write these two numbers in Mayan. So first, to write 100 in Mayan, what you want to note is that using this position system here, which tells us what multiples we have on each row, we don't want any multiples of 360. That's too big if our total number should just be 100. So we don't want anything here or above. We just want some 20s and then maybe some 1s. So how many 20s can you use? Well, we could get 5 in here, and the way you write 5 is kind of with this bar right here, which indicates that I have 5, and since it's on the second highest row, second lowest row, I guess, I know that this would be 5 times 20, which is 100. And if I get 100 from this row, I don't need anything in this row. However, I need to write something here so that you know, or the reader knows, that these are 20s and not singles. And the way I do that is I put this little weird conch shell looking thing here. And that indicates that I don't want any singles. And you add those up, you get 100. You can do the same type of thing, although it's a little bit more challenging to write the number 1 million. You'll have nothing on the top row here because these are multiples of 2.8 million. But you will want some multiples of 144,000. To figure out how many, I can take 1 million and I can divide that by 144,000. And that gives me 6 point something. So what that tells me is I want 6 on this row. So maybe in a different color, I'll represent 6. The way you represent 6 is it's 5 and 1 more, gives me 6. And 6 times 144,000 is equal to, well, I can come up to my calculator here and just type that in. 6 times 144,000 would be 864,000. So I've used a lot of this number here. How much more do I have left? It looks like I have 136,000 left to write on rows beneath this row. So how am I going to write 136,000 in terms of 7200s? Well, let's see how many 7200s go into 136,000. Whoops, wrote that backwards. 136,000 divided by 7200. And I get 18 and change. So what that means is I want 18 here of these 7200s. And the way I write 18 is I say it's 5, 10, 15, 16, 17, 18. And 18 7200s is 129,600. And so if I subtract here, I guess I could use my calculator, although I think it's a little bit quicker to just kind of do it by hand. I get 6,400 left over. So 6,400, well, I can write those in terms of 360s. I can say 6,400 divided by 360. And that's 17 and change. So I want 17 of these 360s. The way I write 17, 5, 10, 15, 16, 17. And 17 times 360 is 6120. I guess I forgot to write how many I had here. That was 129,600. The 6120 I want to take from here. Getting down to the end here, I have 280 left over. 280, can I write that in terms of 20s? I sure can. How many 20s? Well, you might be able to just do it in your head and see that there's 14. Or since I've used a calculator this far, you could do division. It divides evenly, which is kind of nice. It tells me that 14 of these 20s will give me exactly the 280 I need. I can write 14 as 5, 10, 11, 12, 13, 14. Take away 280. I'm done, kind of, since I have no remainder, but I don't want to leave my answer like this because the reader wouldn't know that these represent 20s and not 1s. So again, I put the little conch shell thing at the bottom to represent that I don't have any singles in this case. And so over here, I guess I say 0 1s. Add these all up, and you get the number 1 million. Missing a few zeros there. There we go. Here is this one, and here is this one. Okay, I think that's more than enough on different number systems. Venn diagrams. Kind of challenging too. You're given 6 different statements and trying to figure out which Venn diagrams those correspond with. Okay, well, this first one, P intersect Q. Maybe I'll just draw my own little Venn diagram here. Here's P, Q, and R. P intersect Q, maybe I can make that in red. That would be this shaded region right here. And then P intersect R would be this shaded region in green here. And I'm running out of colors, but that's okay. Q intersect R. Here's Q, here's R. So that's this region right here. Looks like I have all of this area so far. Oh, and then I want to tack on Q. Maybe I should switch colors. All right, let's do orange, I guess. Tack on Q. Q is this guy up here. And then finally, need another color here, black apparently, for R. I'll tack that on because these are all unions. R is this bottom guy here. So what I have shaded in looks a lot like this guy up here. So I would say that diagram C is what I've represented here. The next one, I'm going to do another Venn diagram. So I'm not sure how else to show my work here. I guess you could do it by numbering the different regions, putting elements in them, and talk about what elements are in each one. But I've gone this far. R complement. R complement is everything that is not in R. Well, here's everything that is in R. So R complement, we're talking about all of that stuff. All that stuff in orange right there. But that's not what I want because I want to take away the complement of P union Q union R. So P union Q union R are all, maybe I need more colors. I certainly need more colors. P union Q union R complement would be everything that's not in the union of those 3 things. So really in green here I have the outside part. So what I want to do is get rid of this outside part. And if I get rid of this outside part, it looks like what I'm left with is a little bit hard to see. This region right here. So now I want to look for the drawing that has that region right there. Oh, here it is. Looks like it's F. Guess I don't have to write diagram each time. That's a little obnoxious. Moving on. On this one, you start with P union Q. Okay, I can do that with a diagram. So P union Q is everything that's in these top guys up here. So I got that in blue. But then from that, I want to take away P minus Q. So let's see, P minus Q is everything that's in P is what I start out with, this thing right here. But then I want to take away everything that's in Q. So P take away Q would be that red region right there. And so I'm getting rid of that, so what I have left is the stuff in blue. And then I also want to get rid of Q take away P. Well, Q take away P, we start with this whole Q circle and take away all this stuff. I'm getting rid of this green here. What I'm left with for my final answer is just this darkly shaded region. And it looks like that matches up with diagram A. Okay, Let's see. P complement, take away Q complement. That one's a little bit tricky. Let's take a look at the picture. So let's see. P is this circle right here. So P complement would be everything except for that circle right there. And from that, I want to take away Q complement. Well, let's see. Q complement is everything that's not in this circle right here. So I want to take away all of this. How about I will represent this entire thing in red. I want to take away everything that's not in this circle right here. That just leaves me with this region right here. But then I'm not done. I want to intersect that with R. Well, let's see. R is this bottom guy right here. So if I intersect that with R, maybe that's underlining the whole thing, I'd just be left with this little region right here. So which one has just that little region? Looks like diagram B does. Okay, couple left. I guess I could do either one of these two, and then process of elimination would tell me the other one. I'll do this guy here. Q is what I'm starting out with, and Q is the one in the top right. So that's this circle right here. This is Q. And from that, I want to get rid of something. Specifically, I want to get rid of anything that is in either P or R, the union of P and R. So the way I can come up with that is I want to get rid of anything that's in either of these circles. So I kind of want to erase this part. And what I'd be left with is this red region right there. So I'm looking for one that has that red region. It looks like this guy does. That's diagram D. So that would be diagram D here. And so process of elimination, A, B, C, D, F. It looks like I'm missing E. The claim is that this thing right here represents this. Well, let's see. This is starting out with everything, and then get rid of, I really wish there were parentheses here, get rid of the union of P complement, Q complement, and R complement. So get rid of anything that is not in P or not in Q or not in R. So when I say the things that are not in P or not in Q or not in R, I'm talking about everything except for this little region right here. Right? Because not in P is everything that's out of this circle. Not in Q is everything that's out of this circle. Not in R is everything that's out of this circle. The only thing that is not out of any of those three circles is this tiny little middle part right here. So what this thing is saying is start out with the union and get rid of damn near everything. Get rid of everything except for this tiny little middle piece. You're left with diagram E. These are horrible pictures, bad solutions. I hope these help somebody a little bit, although I'm not convinced they will. But at least you got the answers written here so you can check those against your answers. I'm going to end this video here because it's too long.